So welcome to this latest video 162 Maths, and in this video we'll be going over some GCSE Maths exam questions related to ratios. Now as always, I'll then go through in this video what it is you actually need to revise, and I'll also include some links to lessons which go over those points in greater detail. Now I'll also include a copy of the questions that we go through in this video as a link in the description for you to click on and download and have an attempt at, which I strongly recommend you do so you can test your prior knowledge. Now before we get started working through some past exam questions related to ratios, let's just have a quick overview over what it is you need to revise when covering this particular topic. Now if you're wanting access and you're not sure about any of the things that we mentioned, all you need to do is simply click on the link in the description. I'll include a lesson which goes over each of these particular points in greater detail. So the first thing you need to be able to do is to recognize how to simplify a ratio. So again, we simplify ratios in the exact same way as we would simplify a fraction. Remember that we tend not to include decimals in ratios, and unless it's a 1 to n question or n to 1 question. So just be mindful of not including decimals in a ratio, but also when dealing with units, make sure that the numbers in the ratio are all the same, and that applies to scale drawings as well. So if you've got a scale of, let's say, 1 centimeter equals 3 meters, then in order to correct that scale, you'll need to make sure that both the numbers in that scale are the same unit. So you'd have to do 1 centimeter equals 300 centimeters. So just be mindful of that. The next thing, and the most common one, is know how to share a ratio. So this is where you add the number of parts, divide it from the amount, and then multiply by the respective number of parts that you're actually wanting to find. The next one is knowing when you haven't got the total, but you know how much one part is and you need to find another. So this is where you need to look at the ratios. You don't total up the total number of parts. Instead, you divide the amount by how many parts that thing relates to. So again, I'm sure me going over this is not making much sense, but if you just click on the video that goes through this in more detail, I'm hoping you'll totally understand what I'm saying. The next one is converting ratios into equations. Now this is relatively new, but it's becoming a lot more prominent on exam papers. So whether it's actually involved in the question or whether ratios are being used as equations to then go on to something more algebraic. So again, be mindful of knowing how to convert ratios into equations and vice versa. The next one is converting how to combine A to B and B to C to make A to B to C. Now again, in order to do this, what you want to try and do is find a common part. So you find which letter appears in both. So in this case, B appears in both. And then what you then want to do is manipulate the ratio so that you've got the same number of parts in both the ratios of B, and then you can then combine A and C. And again, if I'm making absolutely no sense, do not worry, the video does go through it in more detail and explains it a lot better and a lot longer than the 5 seconds I've given it. And the next thing you then need to be able to do is to know how to write and understand a ratio when given as a fraction or percentage. And again, the wording of this tends to become a lot more apparent in recent test papers, where they're saying like x is 40% of y, or x is 3/4 of x. So it's really important that you're able to understand that and then convert that into a ratio, which again, I believe in one of the questions that we go through in this particular topic test covers just that. Now the next thing to remember is that there is a massive influence of ratio and proportion, and exam boards now are wanting to incorporate ratio and proportions into virtually every single topic in maths. So don't be surprised if you find a ratio question involved in something quite obscure as a math topics that you may have not seen before. So ratios in histograms, ratios in circle theorems, ratios in direct proportion. So there could be extremes topics which you never thought ratio and proportion could be in, but again, this is where they try and reinvent the wheel of adding ratios into different situations. So just be mindful and always think about the basics when it comes to ratios. So even though when you see a ratio in, let's say, a angles question, just think back, right, okay, what do I do with angles? Okay, do I know the total or do I know one part? And then go from there. So with that all said and done, now let's have a look at some past exam questions. Now again, a little reminder, if you want access to these questions, all you need to do is just simply click on the link in the description. So looking at question 1, it says simplify 24 to 60 to 84, giving you your answer in its simplest form. So here I notice that all the numbers are even, so we can divide all the numbers by 2. So then that becomes 12 to 30 to 42. And then I notice that all the numbers are even again, so I can divide by 2 again. But if I think a bit bigger, I can see that all of them are multiples of 6. So divide all the numbers by 6. Then I'm going to get 2 to 5, and that's going to give me 7. So the answer then is 2 to 5 to 7. Now if I gave any correct simplification of 24 to 60 to 84 that wasn't 2 to 5 to 7, I would get one of the marks. But if I wrote down 2 to 5 to 7 straight away, I'd get 2 marks regardless. So again, not much working out if you can see it straight away. So if you can see that all of those numbers are multiples of 12 and you get straight to 2 to 5 to 7, then you'll get 2 marks because you've simplified it in its simplest form. Moving on to question 1b, it says simplify 25 millimeters to 6 centimeters, giving your answer in its simplest form. Now again, one thing you need to remember or spot that the units are different. So either you convert them both into millimeters, so that's going to be 25 to 60, and then you go and simplify. So if I divide both things by 5, I get 5 to 12, and there's an answer. Or I could simplify them both into centimeters, in which I get 2.5 to 6, in which I can't have decimals, so if I multiply that by 2, I get 5 to 12, and as you can see, I've got the same answer there. So regardless of which method I've got, I get an answer of 5 to 12. Then moving on to 1c, it says that a bag contains 54 marbles. There are 30 red marbles and the rest are blue. Work out the ratio of blue marbles to red marbles, giving your answer in its simplest form. So here we know that the total is 54. We know that there are 30 red. So to work out the blue, it's going to be 54 minus 30, which is 24. So then taking these two numbers here, I get red. Oh, I want blue, so always make sure you're reading the question carefully because I made that slip there. So I've got blue to red. So here we've got blue to red, and that is going to be 24 to 30. And then I can divide both numbers by 6, so that's going to be 4 to 5. Then moving on to question 1d, it says share 338 in the ratio 5 to 8. So again, what we do here is we add the number of ratio parts, which is 5 plus 8, which is 13. So I'm going to do 338 divided by 13. Any which way you want to do that, we get an answer of 26. So then all that's left for me to do with the ratio 5 to 8 is times that by 26 times this by 26. Now on non-calculated paper, numbers will be a lot nicer, but the method is exactly the same. So just be mindful, though these questions, if you're revising for a non-calculated paper, may think, oh, this is never going to come up. Same question come up, just be easier numbers. So here we've got 5 times 26, which is 130, and we've got 8 times 26, which is 208. So the answer then is going to be 130 and 208. Now in this particular question, it doesn't really say, because it says and, I probably could write those numbers in any other order, but try and write your answer in the same way as the ratio is. So if the smaller part is mentioned first, give your smaller answer first. If your bigger answers, a bigger ratio part of the ratio is given mentioned first, give the bigger answer first. So just be mindful of that. Moving on to question 2, it says Farmer Giles plants carrots, onions and potatoes in the ratio 4 to 7 to 15. He plants 1,540 onions. How many vegetables does he plant? So let's first of all label the ratio. So we've got carrots, we've got onions, and we've got potatoes. And we've got 4 to 7 to 15. Now in the information it tells me that I've got 1,540 onions, so 1540. So that means that 7 parts equals 1540. So then if I then work out what 1 part is by dividing by 7, I get an answer of 220. So then if I multiply 4 by 220, I get an answer of 880, and if I multiply 15 by 220, I get an answer of 3,300. So then the total number of plants is going to be those three numbers added together. So it's going to be 880 plus 1540 plus 3300, which gives me a grand total of 5,720. Moving on to question 3, it says the ages of Sarah and Ben are in the ratio of 6 to 5. Sarah is 78 years old. How old is Ben? So again, writing the ratio and labelling. So we've got Sarah, we've got Ben, we've got 6 parts to 5, and it tells us that Sarah is 78. So taking this, what I know is that 6 parts equals 78. So if I then work out what 1 part is by dividing by 6, I get an answer of 13. And so therefore 5 parts, which is Ben's age, is going to be 13 times 5, which equals 65. So Ben is going to be 65 years old. Moving on to question 4, it says Jake, Kim and Lee share money in the ratio 1 to 3 to 6. Kim gets £9 more than Jake. How much does Lee get? So again, setting up my ratio, I've got J, K and L, and I've got 1 to 3 to 6. Now it says that Kim gets £9 more, so you can see that the difference here is 2 parts, and 2 parts represents £9. So if 2 parts equals £9, then 1 part is going to equal £4.50. So then to work out how much Lee gets, well, Lee equals 6 parts. So 6 times 4.50 gives me an answer of £27. Moving on to question 5, it says Raj is mixing concrete, cement, sand and aggregate are to be mixed in the ratio 1 to 3 to 6. He has 0.5 cubic meters of sand and plenty of cement and aggregate. Can he make 2 cubic meters of concrete? Show you working to support your answer. Now again, it's very tempting to tick one of those boxes before you give your reason. So, but here, always try and work out the question and then tick the box at the end. So here, let's have a look. So we've got the ratio of cement to sand to aggregate, and we've got the ratio of 1 to 3 to 6. Now it says he has 0.5 cubic meters of sand. So that means that 3 parts equals 0.5. So then to work out 1 part, I do 0.5 divided by 3, which on the calculator gives me an answer of 1/6, which is 1/6 or 0.16 recurring. So then in terms of the cement, that's going to be 0.16, that's 1 part. Then to work out the aggregate, I'm going to times that by 0.16 recurring, and I get an answer of 1, which makes sense because if the sand to aggregate is double, so if I double 0.5, that's going to give me 1. So then the total amount is going to be 0.16 plus 0.5 plus 1, which gives me an answer of 1.66 recurring. So is it enough to make 2 cubic meters? The answer then is going to be no, and 1.6 recurring is less than 2. Then moving on to question 6, it says that Kay and Tom share £540 in the ratio of 7 to 3. Kay gives some money of her share of her money to Tom. Tom now has the same amount as Kay. How much did Kay give Tom? So first things first with this question, let's see how much they originally had. So at the start, they both had, so we've got Kay and we've got Tom in the ratio of 7 to 3. So we do 540 divided by the total number of parts, which is 10, which is 54. So if I then multiply 7 by 54 and 3 by 54, then I get an answer of 378, and I get 162. Now, for them to have the same amount, we do the total amount, which is 540, divided by 2, which is 270. So that means at the end they want £270 each. So then there's a couple of ways in which I can then do this. So either I can do 378 minus 270, or I could do 270 minus 162, in which then I should get an answer of £108, and that is how much Kay has given Tom and Tom has received. So the answer then is 108. Then for question 7, it says that x is 3/4 of y. 3z equals 5y. Work out the ratio of x to y to z. Give your answer in simplest form, where x, y, and z are all integers. So taking this first statement here, we know that x is 3/4 of y. So x equals 3/4 of y. Now what we want to do is want to get x over y. So if I take the y over to the other side, I end up with something that looks like this. And when I've got a fraction equals a fraction, I can then write this as a ratio. So x to y is going to equal 3 to 4. And I'm just going to put a little box around that. Then moving on to the next bit of information, I know that 3z equals 5y. So again, if I do the same, but this time I want to make y the subject. So it would take the z over to the y. So I've got 3 over 5 equals y over z. Then if I do exactly the same, then what I get is I get y to z is equal to 3 to 5. Now what I can then do is merge these two ratios together. So I've got x to y to z. Now if I write down what I've got in green, I've got 3 to 4. And if I write down in orange underneath that, I've got 3 to 5. Now what I want to do at this stage is I want to have the same number of parts for y. So I think to myself, okay, what's the lowest common multiple of 4 and 3? Well, that's going to be 12. Let me try and not write with a highlighter. Oh. There we go. So I can see that I've got a 12. So looking at this first fraction, what have I multiplied this so that the y is 12? Well, I've multiplied that by 3. So then 3 times 3 is going to give me 9. And then for this fraction, if I wanted y to equal 12, what have I multiplied 3 by? Well, I've multiplied that by 4. So if I then do 5 times 4, I get 20. And there is my ratio. And just got to check, can I simplify that? No, I can't. So the answer then is 9 to 12 to 20. Then moving on to question 8, it says x to y is equal to 5 to 2. Write an expression of y in terms of x. So again, very similar to what we previously did. So if I write this as a fraction over each other, so x over y, and that's going to equal 5 over 2. Now the question wants me to make y the subject. So if I do a bit of cross multiplying, I get 2x equals 5y. I want to then get rid of the 5, so it's 2x divided by 5 equals y, and that there is my answer. So y equals 2x over 5, or you can write it as 2/5 x, or you could write it as 0.4 x. So any of those would be absolutely fine, but make sure you do write equals y. Then moving on to our last question, it says screen wash is diluted with water to put in the washer bottles for car windscreens. 1 litre of bottle of screen wash costs $3.99. In the winter, screen wash to water is used in the ratio 1 to 2. In the summer, the ratio is 1 to 9. Joe's car has a 3.5 litre washer bottle, which is empty, and he needs to be able to fill it up 5 times in the winter and 3 times in the summer. And the question's asking how much will it cost him to buy the screen wash to be able to do this. So let's have a look at working with this question. So first things first, we've got winter and we've got summer. So let's first of all look at the winter. So in the winter, we know that the number of litres needed is going to be 5 times 3.5. So it's 5 times 3.5, which gives me an answer of 17.5 litres. So that's how many litres I'm going to need of screen wash. Now from this, what I then need to do is I then need to use this ratio to work out how much of that 17.5 is going to go on screen wash and how much of it is going to go on water. So here I've got screen wash to water, and I've got the ratio of 1 to 2. So then that's 3 parts. So 17.5 divided by 3 gives me an answer of 17.5 divided by 3 gives me an answer of 5.83 recurring. So in the winter, I'm going to need 5.83 recurring litres of screen wash, and I'm going to need, although it doesn't really make a difference, 11.6 litres of water. But it's only the screen wash that I'm interested in, so I'm just going to highlight that. Then if I do the same calculation but for the summer, so in the summer, the number of litres needed is going to be 3 bottles, so it's going to be 3 times 3.5, which gives me an answer of 10.5 litres. So then from this, I've got the ratio of screen wash to water, which if I just scroll up is in the ratio of 1 to 9. So then if I then do 10.5 divided by the number of parts, because 10.5 is the total amount of liquid that I need, divided by 10, that gives me 1.05. So then if I multiply 1 by 1.05 and 9 times 1.05, then that becomes 1.05 litres of screen wash, and 9 times 1.05 gives me 9.45 litres of water. Now again, I'm only interested in the screen wash, so then the total amount of screen wash needed, I'm going to use a pen that I've not used, so the total amount of screen wash needed is going to be 5.83 recurring plus 1.05, which equals about 6.88. So that means I'm going to need to buy 7 bottles. So 7 bottles needed. So then from this, if I just move down, I'm just struggling with space here. So then 7 bottles equals 7 times 3.99. So then all I've then got to do is 7 times 3.99, and it gives me an answer of £27.93. And there we go.